right, so our next gas law is Charles' law, which shows the relationship between volume and temperature. And once again, just to remind you, this temperature must be, as always, like I said, in Kelvin. None of these gas laws will hold true as far as mathematical relationships if your temperature is in Celsius. So if you increase the temperature of a gas in a container, and that's, again, a container now without a fixed size, that means the container can change its size, you will increase the speed of those particles. Why? Because you're increasing the temperature. That means the kinetic energy of the particles will increase, and that will increase the number of collisions. Those collisions will increase the collisions with the walls of the container and push on the walls of the container and push the container walls out. So imagine you have a container again, and if you have a container that can slide out, if you have your gas particles moving and they're moving faster and faster, this will push and increase the volume. So as temperature increases, the volume will increase. That means that they are directly proportional. The equation V over T equals K. We have our K as our constant. We will use it in the form of V1 over T1 equals V2 over T2. So let's go ahead and use an example here. A container holds 50 milliliters. So we have a volume at 25 degrees Celsius. What will be its volume? So we have another volume mentioned. And if the temperature increases by 35 degrees Celsius. So that's a little tricky there because it says it increases by 35 degrees Celsius. So let's make our table. Our V1 is 50 milliliters. T1 is 25 degrees Celsius. That means we're at 298 K. 298 K. Apologize there. V2 is what they're looking for. In T2, now it's 25 degrees Celsius was our original, and it says it increased by 35 degrees Celsius. So that means we're at 60 degrees Celsius. Add 273, and we're at 333 Kelvin. All right, our equation again, V1 over T1 equals V2 over T2. I'm going to do some plugging and some chugging. That's a phrase from when I was young, a long, long time ago. T1 is 298K. V2 is our unknown. T2 is 333K. We cross multiply here. So remember, we cross multiply what we know, divide by the other one, and so we're multiplying 50 times 333 divided by 298, and we're going to keep about 55.9, and our unit is milliliters. All right, our next one, we have a sample of hydrogen found to have an initial temperature of 50 degrees Celsius. The volume of the sample is reduced from this volume to this volume. So we have a V1 and a V2, and they want to know the final temperature. So we're looking for a T2. So we have a V1, a T1, a V2, and a T2. V1 is 45.6 liters. T1 is 50 degrees Celsius. V2 is 35.7 liters. And T2 is our question mark. Temperature, remember, has to be in Kelvin, so we convert that. 50 to plus 273 is 323 Kelvin. Get our equation for Charles' law. Plugging and chugging. This time we're solving for T2. When we do that, this time we're cross multiplying these two because those are the two that we know across from each other. And then we take 323 times 35.7, divide by 45.6, and we get a T2 of about 253K. And that, my friends, is Charles' law. Thanks for listening.